In this short section, we're going to look at software development very, very briefly. And we're going to look at what really drives industrial scale software development. And the first thing that we need to note is the sheer size of a lot of software programs. So we've got some rough figures here from the public domain. Google allegedly is running around 2 billion lines of code in order to deliver all of their products. And then we've got a large operating system like Apple Mac, 85 million lines of code. Facebook, over 60 million lines of code allegedly. Microsoft Office, 45 to 50 million, and so on. And even on my very humble mobile phone, I've got 12 to 15 million lines of code, okay? Now, if we go to something a bit older, back to 1970s and 80s technology, the space shuttle required about 400,000 lines of code to work. And in those days, it had to be handcrafted, and probably a lot of it was assembler. So very, very dense code, still needed 400,000 lines. And apparently even a heart pacemaker these days has got about 80,000 lines of code in it. And the issue here is the sheer volume of code we need to get the functionality that we require, okay? So, you know, to fly the space shuttle, to perform all the functions that it does, we need that amount of code. To get this thing to work, and all the, you know, the many apps on it that you see, or we've got on all our phones, you know, huge amounts of code to get that to all work, okay? And that's what we have to do. Now, the issue with that is that it's inevitable that in development we will make mistakes, okay? We cannot produce a significant amount of code without making errors that need to be corrected in order to get the code to work. That's fine, okay, that's a given. But the cost of fixing defects goes up dramatically as we go through the software development lifecycle. So if we catch something really early in design, we realize we've made a mistake. And it could be something as simple as we've accidentally put a plus instead of a minus in a line of code. You know, let's say it costs us $1 to fix that in design. We spot that and go, that's wrong, fix that. If we're into coding implementation, it's going to cost us more, maybe $6.50, okay? And then as we get into testing, okay, if we don't find it until testing, we've got to go back and fix the code, and then maybe we've got to change the test, or we've discovered something else, there was something wrong in the requirements, and we've got to redo the tests. So we're having to do more and more activities to find and kill those bugs and make sure we have a consistent software set. And then finally, if we actually get the code distributed and in use by people, and we have a bug fix that we have to do, well, it can cost us $100 relatively to fix that bug and do all the things that need to be done, deploy it to all of the users and get it working. So we need to catch bugs and defects in our code as early as possible in order to minimize the costs. And the effect of that on an industrial scale can be quite dramatic. So if we look at, I've got a diagram here from a website, speedandfunction.com, and they are actually quoting the Standish Chaos report. Standish Group do a report on software development metrics every year, particularly on the successes and failures of software project development. And if we look at this diagram, we can see that back in 1992, only around 16% of software development projects completed on time and within budget. Almost a third were completely cancelled, And then the remainder, some 50-something%, were late and over budget. Okay, that was in 1992. Now, the data they had was 2017. So things have definitely got better for completed on time and within budget. By 2017, we've got almost 30% of projects completed on time and within budget. The number of cancellations has dropped to just under 20%, but still 1/5 of all software development programs completely fail. Think about that, 1/5, 20%. Anyway, so software development is a risky business, okay? But actually, I think what's most interesting is that even in 2017, the number of software development projects that were late and over budget is still more than 50%. Okay, so our record in software development is not great, okay, to this day. And a lot of the metrics that you will see me reporting on later may be old, but they're still relevant because, unfortunately, the fundamentals don't change. We still have this massive fundamental problem with getting our software development done and complete on budget and on time. So the things that we have to note about real world industrial scale software development is that we have two drivers. First of all, to complete the project or anything like completion, we have to get the software to work, okay? Not perfectly, just well enough to field it for a minimum functionality project or content to get us started, okay? And we've got to do that before we run out of money and time. And if we think back to that bug fixing exponential curve, that means that we've got to remove enough defects from the software to get it working quickly and cheaply enough to complete the project, okay? That's what is driving us. That's what is driving large-scale software development. And indeed, what we see these days with modern development techniques like Agile is arguably we've abandoned conventional project management altogether with software. So conventional project management, you would have the classic project management triangle where we say, I've got a certain amount of budget, I've got a certain amount of time in order to deliver this amount of functionality or this amount of capability, however we're measuring it, okay? So that's the classic project management triangle. And at the start, you estimate, well, how much time and money is it going to take to deliver this thing to the required quality, okay? Arguably, software development is so risky, we've kind of moved away from even trying to attempt that, okay? We just go, we'll have a quick sprint, we'll develop some stuff and get it to work, and then we'll go again. So we've gone, okay, developing big software is risky, so we'll make it very small. And by the way, we'll be very modest in what we're trying to do. We won't try and aim for huge functionality. We'll get there incrementally. And that's the way modern software development is done, in my view, precisely because of these risks, because we simply cannot afford to keep failing at the rate that we have done. So that was a very quick overview of modern software development. And the reason that I've done that is because the techniques that I've just described to you and the problem that we face with conventional software development is completely inadequate to produce safe software, okay? These techniques will never, in my lifetime or yours, will never allow us to produce safe software. We need a completely different approach. And in the next section, I'm going to explain to you why that is and show you what we need to do and what we need to deal with.